Continuing our study of conics, 10.2 focuses on ellipses. An ellipse is the set of all points xy, the sum of whose distances from two distinct fixed points, which we call foci, is consistent. So just for kind of a picture of that, here's my ellipse. I do have an axis going through it with my two foci. Any point, so let's just say on the ellipse, let's call this xy, the distance from here, from that point to the first foci, we'll call that distance 1 or d1, and then the distance to the second one, d2. No matter where that point is on my ellipse, if I add d1 plus d2, I'm going to get the same thing every time. So these stay the same, not necessarily the same distance, but the sum of their distance is the same throughout the entire ellipse. Okay, so looking at our ellipses, one way to have them is with them going horizontally. So in this case, on these ends, we have our vertices. So this is a vertex, as is this. The top and bottom of my ellipse, those are called my co-vertices. We already talked about having this axis that goes through here. The axis going from your vertex to the other vertex, so between the two vertices, is called your major axis. And you have another axis going between your co-vertices, and we call that your minor axis. In the center where those cross is your center. And this is where we have a lot of important distances. So from the center to my vertex is A. From the center to my co-vertex is B. Then I'm missing my two distinct points, my foci. So one by itself is called a focus, but with an ellipse you will always have both. So that's my focus. And the distance from my center to that is C. You also have a similar setup going horizontally. Whether my major axis is horizontal or vertical does not change where everything lies. So your foci still lie on that major axis, as do your vertices. The major axis is always longer than the minor axis. Your co-vertices lie on your minor axis, and your center is where those two axes intersect. I'm back on my horizontal ellipse. When I'm looking at my points, so actually with both of them, the center, just like it was for my parabola for the vertex there, is HK. Your major axis has a length of 2a. Your minor axis has a length of 2b, which would make sense if the distance from the center to the vertex is a. My major axis would be both of those, so that's 2a. Your minor axis is between the two co-vertices, and I know from vertex to center is b, so going to both of them would be 2b. And the relationship between a, b, and c is similar to your Pythagorean theorem, but it's actually minus. So the distance from my center to my foci, or c, squared is a squared minus b squared. So keeping those a's and b's and h's and k's in mind. Your vertices go, in this case, to the left and right of my center. So it's the x that's changing. you are adding or subtracting a, depending on if you're going to the right or to the left. The y value does not change. For your co-vertices, it's the y that changes. So my h is going to stay the same. The k is going to be plus or minus b. And for your foci, since they're on that major axis, again, it's going to be the x changing, but this time it's by c. The y value will stay the same. I'm going to have similar over here. On the second one, since it's got a horizontal major axis, so basically everything is turned, the vertices keep the same x value as the center, but a different y value. Your co-vertices will keep the same y value, and the foci, since again, they're on the major axis, they'll keep the same x value. Now to our equations. If we have a horizontal major axis, then I have x minus h squared over a squared, remembering that a is just half the distance of your major axis, plus y minus k squared over b squared equals 1. If it does have the center over the origin, then that would just be x squared over a squared plus y squared over b squared equals 1. Again, that's your center at the origin. The other side, it's going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. Again, similarly for the center at the origin. What you need to pay attention to is if my major axis is horizontal, so going across with the x's, then it's the x that has the a squared underneath it, and that's what goes to the major axis. If your major axis is vertical, so changing with your y's, then the y is what has the a underneath it. Let's look at a couple of examples. Draw the ellipse and write the standard form of the equation. An ellipse with foci at 0, 1, and 4, 1. So 1, 2, 3, 4. So 0, 1, and 4, 1. And a major axis equal to 6. First thing, if my foci are at 0, 1, and 4, 1, I know that right in the center of them should be my center. So my center is at 2, 1. Major axis equal to 6. So I should be coming 3 to the right and 3 to the left of my center. Oops, it's not a very good ellipse. I still need to figure out how high that goes and how low that goes. So if you remember, c squared for ellipses equals a squared minus b squared. So c is the distance from the center to the foci, which would be 2. A is just half of my major axis, so that would be 3. So I have 4 equals 9 minus b squared. So b squared equals 5. So b is equal to radical 5. So when I write my equation, since it's got a horizontal major axis, it should be x minus h squared over a squared plus y minus k squared over b squared equals, I'm going to put a 0, equals 1. Sorry about that, I started to write 0. So x minus 2 squared over a is 3, so over 9, plus y minus 1 squared over b squared, so that would just be 5, equals 1. That's my equation for my hyperbola. Looking at that, I can tell how long what my center is, 2, 1. I can tell how long my major axis and minor axis is. So my major axis would be the square root of 9, which is 3, times 2, which is 6. My minor axis would be square root of 5 times 2, so 2 radical 5 for the length of my minor axis. Draw the ellipse and find the center, vertices, co-vertices, and foci. So first off, I need for this to be equal to 1. That is crucial in order for it to be ellipse. It already has your plus here, so that's good. So I'm going to divide everything by 36. Okay, so I do get equals 1 here. This is just going to be y squared over 36. This is going to be x squared over 9. So looking at these, the 36 is bigger, so my y is bigger, so it should be going vertically. Let's see, center. Since there's nothing with my x and my y, I know that both of those are 0, 0. Vertices, co-vertices, and foci. For each of those, I need to know a, b, and c. So if 36 is a squared, that means that a is 6. If 9 is b squared, that means that b is 3. And remember that c squared equals a squared minus b squared. So c is going to be the square root of 36 minus 9, which 36 minus 9 is 27. Square root of 27 is 3, radical 3. So for my vertices, they should land on that major axis, so in line with my center, and it should be the y that is changing, so it should be 0, and then I'm going to have 0 plus or minus 6, since that's my a. So you could list them out as 0, 6, and 0, negative 6 would be totally fine. For my co-vertices, it's going across the minor axis, so it's just the x that's changing. So that's going to be plus or minus 3, comma 0. Again, you're always basing it off of that center. Same as before, you could list it as 3, 0 and negative 3, 0, or you can list it this way. Either way is fine. For your foci, that's going to be on your major axis again. So going back from my center, it's the y value that's changing, and that's plus or minus 3 radical 3. Again, you could list that as 0, 3 radical 3, and as 0, negative 3 radical 3. Either way you want to do that is totally fine. Another example, write the standard form of the equation of the ellipse and find the center, vertices, co-vertices, and foci. First thing you need to do is group your terms. So this is going to be x squared plus 6x. Then I'm going to just kind of leave a space so I can complete the square here. And then 4y squared minus 8y. Leave a space there. And let's go ahead and move my 9 over. So within each of these, I want to complete the square. So I do b divided by 2 squared. So in that one, that's plus 9, which means I need to add 9 over here. This one, before I can complete the square, I have to factor out that 4. So divide by 2 plus squared is plus 1. Because this is 4 times that plus 1, I'm really doing plus 4 over here. So I have x squared plus 6x plus 9, which is just x plus 3 squared, plus 4 times y squared minus 2y plus 1, which would really just be y minus 1 squared, equals 4. If you remember, this has to be equal to 1, so I'm going to divide everything by 4. So I get x plus 3 squared over 4 plus y minus 1 squared over 1 equals 1. Go ahead and see if you can find all of your key points from there. go ahead and check these and then do the next one on your own.